Welcome. This is, I won't write a class number, lecture number all. You can see sequence. Part types of loads, part 3, uniformly varying load, UVL. Now some statement you have to write. I will give here. You should write it. See, I will dictate, space not there. Uniformly varying load or short form UVL can be represented either by a triangle or by a rectangle, or by a trapezium. Okay, either by a triangle or by a trapezium. Now, further you are right. When we consider uniformly varying load represented by a triangle, there are 3 cases. See, you should write. I am not dictating. This all you are right here. There are 3 cases. First one, case 1. See, case 1, uniformly varying load represented by a right angle triangle. Or part 3 actually I will tell you, uniformly varying load, see, UVL, I write here, represented by a triangle. Represented by a triangle. That is the main part. Okay, right here. By a triangle main. That is your part 3. Now, 3 cases are there. Case 1, uniformly varying load represented by a right angle triangle. Case 2, uniformly varying load represented by an isosceles triangle. That is, both sides equal length. I already explained. Last case 3, uniformly varying load represented by a triangle in general. That is something like this. No restriction. Not right angle. See, first right angle, then isosceles, lastly general triangle. Okay. Now we will start for case 1. UVL represented by a right angle triangle. That is 0 intensity at one end and maximum intensity at the other end of loaded length considered. What load considered? That is L0 as usual. Considered L0. That is, you can write, when we consider a loaded length L0 of an UVL represented by a right angle triangle, intensity is 0 at one end of the loaded length and linearly increases to maximum at the other end. Okay. Now, A, subdivision AB. This is not part. Subdivision AB. AB, see, here 0, maximum here. 0 to W. Here, maximum here, minimum here. Not minimum, 0 here. Both the cases, loaded length is L0. Now, those who want, write here. This is the case as per the sketch. Uniformly varying load where represented by a right angle triangle where loaded length is L0. At the left end of the loaded length, intensity is 0, which linearly increases to maximum of W per unit length at the right end. So this W per unit length is the maximum intensity. This is the maximum intensity. Intensity here, same here also. Or, but you should write second time. You can tell here from left side to right side, it is linearly increasing, or from right side to left side, it is linearly decreasing. This case, once again same statement, uniformly varying load represented by a right angle triangle where loaded length considered is L0, intensity as per the sketch is maximum of W per unit length at the left end of the loaded length considered, which linearly reduces to 0 at the right end of the loaded length considered, or from left end to right end, intensity linearly decreases, or from right to left end, intensity linearly increases. This statement you write. Now, what we want, you write. I will dictate what we want. I will dictate. You should write it. 1. Magnitude of the total load for loaded length considered. 1. See, it is not a joke I am telling every time. If you don't write all these things, you will have a problem. 2. Direction, very simple. Directly downward, leave it. 3. Line of action of that total load. 4th one, moment of that total load for the loaded length considered about the two ends of the two end point of the loaded length, that is A and B, and also two additional points. 1 point to left side of A, 1 point to right side of B. I will call this C and D. Let it be x1, let it be x2. Or you write from the extreme left end of the loaded length, further go by x1. From extreme right end of the loaded length, go right by x2. Okay. This is what we require. Okay. Now, I will write one by one. So, okay, first one, magnitude. See, this I will remove now. None of them required now. I want space. I want now space for all these. Start. First, what all I dictate, you write. First, magnitude. Class after class, I am shouting. When you write magnitude of total load, your hand has to move this way. This is not magnitude, it is intensity. So, magnitude like this, where if it is UDL, exactly center. It is right angle triangle. I told line of action of the total load will pass through centroid of the diagram representing the load. This is L0. So, centroid will be somewhere here. This side, here, this is L0. Centroid will be somewhere here. This I told very clearly. So you write here centroid G. Centroid will be on that side where area is more. See here, area is more that side. So centroid will shift that side. From center, it will shift that side. Here, shift this side. Through this point, see, this is, I write here now, arrow mark, okay. This is magnitude of total load for loaded length considered of L0 equal to, I told very clearly, in case of UDL, multiply the intensity with loaded length. Area is not considered. But uniformly varying load, whether you represent by a triangle or trapezium, whatever you do, you just write given by area of loaded diagram equal to half into L0 into W, equal to half into L0 into W. Put a bracket. This is the direction, see, downward. Downward already shown there. Now you can write here. This is that total load. See, when you finish this one, that means this arrow mark will come now. This is the total load. Okay. Now, further, how you got? Right here. You write here, given by area of diagram is here triangle, diagram representing the loading, representing the UVL, which area? For loaded length considered. This is a very, very important term. Loaded length considered, that is L0 loaded length. This much you write. Now, here, once again same way, it is half into L0 into W. Close the bracket. Now, you do one thing, to save the time, put arrow mark here. Same statement here also. Or you write here. For this also, you write the same statement. Once again write here. Those who are serious, once again write here. magnitude of total load for loaded length considered equal to half into L naught into W, that is for loaded length given by area. Okay, now where is line of action? Okay, make a note. Line of action of that total load will pass through centroid of loading diagram, of load diagram. Okay, load diagram is, here it is triangle, right angle triangle. Now that is further, that is at, see, correct, clear. If I look this sketch, you should write this 2 times. I am writing this one for case A. See, I am writing for case A. That is at, I told very clearly, what? This is 2 by 3 of L naught. This is 1 by 3 of L naught. Here, this is, space is not there. I'll remove that one. Okay. This is 1 by 3 of L naught. This is 2 by 3 of L naught. You write for this one. See, this statement for A you write right here. Not there, right here. That is at 2 by 3 of L naught from A, or at 1 by 3 of L naught from B. That statement you are right for here. See, this statement you are right here. Then for this one statement required, I'll remove. I write statement for B sketch, B. This statement you are right here. That is at the interchange. Now from A it is 1 by 3 of L naught from A, or 2 by 3 of L naught from B. The last statement you write here. Now magnitude over, direction over, line of action over. Lastly, moment about A, B, C and D. For both cases, new sketch I will write. I will continue. You also write separate sketch. See, last time I told for both magnitude, direction and line of action over. Now moment. For that, A continued, B continued. See, all this I explained, L naught. Now first, those who want to make a note, this I will not tell again and again. When you want to moment about any point, put your finger there. First 2 terms are there when you want to moment. This is moment distance, this way. This is magnitude of total load. See, hand should move like this into perpendicular distance from that point means about which you want to moment, to line of action of this total load. This I told many times earlier. So if I write here, it will be insult to everybody. Okay, start. For that, last time, see, solid line we marked magnitude. This time, no. See, later on, see, somewhere here. Light line. This is the, right here, if you want, write. This is the magnitude of the total load, right? Somewhere here, light line. See here. Both you are right systematically. This is magnitude of the total load for loaded length considered equal to L naught. How you got it? This is area of the triangle. I already told you half into L naught into W. This also half into L naught W. So when you want to moment about any point, the total load is half into L naught into W. Here also half into L naught into W will give you total load. into, see, now do one thing, light line, very light line, 2 by 3 of L naught, light line right here, 1 by 3 of L naught, very light line here, 1 by 3 of L naught, 2 by 3 of L naught. Okay, now start. Moment about A, finger should be here. Total load already over into this distance into 2 by 3 of L naught. It will be clockwise. Okay, now I'll complete this one now. Okay, moment about A over, come to moment about B. You should see, those who are serious should once again write equal to about B. Total load already over into 1 by 3 of L naught. You should not do this way. You should not do this way. 1 by 3 of L naught anti-clockwise. I am writing, I am adjusting it here. I am teaching, you are learning. You should write every time. Okay, now, moment about C. Moment about C. Once again, finger should be here. Total load already over into, from C to this line of action, x1 outside distance, it is x1 plus from here to here is 2 by 3 of L naught. Moment will be clockwise. Okay, write this one. Lastly, write moment about D. Remember, you have to write 4 times. Moment about D. Total load already over half into L naught in W into, from here, x2 plus 1 by 3 of L naught. It will be anti-clockwise. Over. Now, go there. Now a little fast I will tell. When you want moment about A, the total load into 1 by 3 of L naught. Okay, over. Next. When I want moment, this is clockwise. When I want moment about B, the total load into this distance. So, afterwards, write once again about B, it will be total load into about B. You have to write once again into anti-clockwise, 2 by 3 of L naught. I think that anti-clockwise mark is not out of camera. Sometimes what happens is, yes, it is slightly going out of camera. I shift the camera. Okay. Okay, now okay. Slightly going out of camera. Okay, okay. But I am telling in the words. It is anti-clockwise. Next. Moment about C. Total load into x1 plus 1 by 3 of L naught clockwise. Lastly, everything over. Moment about D. Total load into here x2 plus 2 by 3 of L naught. It is anti-clockwise. Remember, if you want to really learn, 4 times you have to write here, 4 times you have to write here. It is a permanent. Once you make a fair copy, it is a permanent. Okay. Now, I will go for numerical part. Numerical example. For that one, I will adjust the board. 1 minute. I will adjust the board. Start numerical example. Do not see below this line. Right now, do not see below this line. Do not see. You see only upper side. This is comes later. I wrote because to save the time. Okay, start. Right here. A. Those who want uniformly varying load represented by a triangle subdivision case 1 represented by a triangle case 1 or A or case 1, okay, by a right angle triangle. Here, zero intensity at the left end linearly increases to 60 kN per meter at the right end, and load is spread for a length of 8 meter. These numbers is my choice. Over. 2 points are considered C and D. C left side 2.5 of A, D right side 1.6 meter. After completely over, when you go there, you write uniformly varying load represented by a right angle triangle, left side maximum intensity 90 kN per meter. As you go to right side, linearly decreases to 0 at right end, and loaded length is 10 meter. 1 point C here, I decided 2.2, 1 point that side by 3.6. Right. Now, what we want is same thing. Right there if you want. What we want? 1, I wrote last time, magnitude of the total load. See. Solid line. Magnitude of total load. Magnitude of total load. I told last time, when you tell magnitude, it should come like this. Total load for loaded length considered of 8 meter equal to, see how I told, is given by area of the triangle half into 8 into 60. When you finish, put a bracket here. Direction is down. Kilonewton. If you want, write here. Given by area, I am dictating now, area of the diagram representing the load for the loaded length considered, that is area of the right angle triangle for base length of 8 meter is half into base into height. You write. Later come here, or you write sub in the same page, big lengthwise you write. Left side this one, right side that one. Here see. Once again write what I wrote here, write once again. If you are lazy, if you don't write, you are losing. Magnitude of total load length, total load for loaded dead considered of how much? Not 8 meter, of 10 meter. Equal to, right here, half into 10 into 90, whatever you get is in kilonewton, direction is down. Okay, this is over. Right, or right here if you want, given by area of the triangle, write that one. Okay, now, direction, magnitude over, direction over, line of action. Now you should write. I will dictate here. Line of action of that total load for loaded length considered will, there is no L0 now, will pass through centroid of the diagram representing the load. Here, centroid of the right angle triangle, that is here, that is from here to here is, this is 8 meter, 2 by 3 of 8 meter, from here to here, 1 by 3 of 8 meter. Now do one thing. You write right here. You write here. If you want to learn, write. Line of action of this load will pass through centroid of the diagram representing the entire loaded length considered, that is at 2 by 3 of 8 meter from A, or 1 by 3 of 8 meter from B, you write here. Okay, now, here. This is 1 by 3 of 10 meter. This is 2 by 3 of 10 meter. Once again, right here, after getting magnitude, see, after you finish everything, right here. Line of action of this total load for loaded length considered of 10 meter will pass through centroid of the diagram representing the load, that is centroid of the right angle triangle for entire loaded length of 10 meter, that is at 1 by 3 of 10 meter from A or 2 by 3 of 10 meter from B, this much you write first. Okay. Now, magnitude, direction, line of action over. Now moment. Okay. When you want moment, see, what I will do is, I won't waste time now with the cloth and rubbing to here. Now, I will remove this one. You write one more sketch now. See. Now, this is not there. None of this is there now. None of that one. Write separately both. If you want to learn everything, follow what I tell, systematically follow it. Okay. Right. Next moment. You also write below one more sketch. Don't be lazy and do here. Laziness means you won't learn. Right here and right here. Okay, right. I can lift this one now, leave it. Now, some space is wasted. Those who want, write. I am telling this one for 100 times. Moment of the total load about any point equal to magnitude of the total load, magnitude of total load multiplied by perpendicular distance. See, that into is here. Perpendicular distance from that point. That point means about which you want moment in the bracket. To, not a numerical to, TO2, to line of action of the total load. Write systematically. Now do one thing. Without disturbing the diagram, light line, mark CG. Light line. Now see, because later this marking you are not doing. Light line. You can write here. This is the magnitude of total load. Here, light line. And right here, this is magnitude of total load. How to, you know how to calculate. Then, again, light line. Using pencil, 2/3 of, not L naught now, 2/3 of 8 meter. This is 1 by 3 of 8 meter. Here, 1 by 3 of 10 meter. This is 2 by 3 of 10 meter. This much you write. Okay, now start. Once again write 2.5, 8 meter, 1.6 meter. This space is wasted now. Okay, start. Now systematically. Moment of the total load for a loaded length considered of 8 meter, that is entire load about A equal to, see here, finger A, magnitude of the total load equal to, you should write here, this is the magnitude, this is distance. First is the magnitude, this is the distance, magnitude. Half into 8 into 60 is the magnitude. See, this will give you magnitude. Into, from A to line of action is 2 by 3 of 8. That much kilonewton meter in clockwise direction. Okay, moment about A over. Now, below write. You write below. I will rub and write here because I am not learning, I am teaching. B. About B, right. Total load, same, half into 8 into 60 into, from B, 1 by 3 of 8. Anti-clockwise, kilonewton meter. Then below write about C. C, finger here now. Total load, same, half into 8 into 60 into, from C, 2.5 plus further distance of 2 by 3 of 8. 8. Clockwise. Clockwise. Some will tell teaching is very easy because you can rub and do. Oh, teaching easy, okay. Then lastly, completed now. Further below write moment about D. About D. Total load already over into 1.6 plus 1/3 of 8 anti-clockwise. You show me a place where this much explanation, once for bookwork type W and L, once for numerical, so much clarity, so much explanation, so much in detail given. You tell me where. Okay. That is, I told you, I have infinite patience when I teach. I see that everybody will understand thoroughly. Okay, start now, here. Moment of the total load about A. Now loaded length is 10 meter. Start about A. Total load half into 10 into 90 is the total load. Into about A 1/3 of 10. 10. Clockwise. Kilonewton meter clockwise. Okay. A over. Now, next, don't write here. Below write same statement once again. Once again write, but about B. Total load, same, into, from B, 2/3 of 10. Oh, I maintained that one only. 2/3 of 10. Anti-clockwise. Kilonewton meter anti-clockwise. Okay. Next. Then further below write moment about C. Total load into, from C, 2.2 plus 1/3 of 10. Clockwise. Kilonewton meter. Lastly write further below moment about D. Total load same into, from D, 3.6 plus 2/3 of 10. It is anti-clockwise. Over. This will, now, someone asked, sir, last time, sir, for UDL, you told something special. Suppose you require some point here, either left or right, what to do? That I will not do now, because suppose you want, here, see, suppose you want, for some reason, moment of the total load somewhere here, I think Q point I have taken, either to left side or to right side about Q. Then if you look left side, you get once again right angle triangle. But if you look right side, you get a trapezium. Still trapezium we are not covered. Therefore, this part, that special part of finding total load and moment concerning any one side, I will tell by example after everything is over. So, this is your part, types of load. What I have done is types of loads, part 3. Part 3 is for UVL. There, today I finished case A. Case 1, not case A, case 1. Uniformly varying load represented by a right angle triangle. Next class will be same part 3, case 2. Uniformly varying load represented by an isosceles triangle. That will be over very fast. Why? Very, very easier. But okay, one short class. Once I finish that one, next part 3, uniformly varying load, over that represented by a triangle in general, random. See, random. That will be case 3. With that one, part 3 will be over. Uniformly varying load represented by triangle. Then I will go to part 4. That is uniformly varying load represented by a trapezium. Once I finish that one, then I will tell that important concept for all the cases. UDL already over last time. I will include UDL also, so that one class, everything thoroughly. Okay, now, if you are serious and really want to learn, I told you these all, if I tell what all I dictate, what all I write, you should also write. Okay. We will meet in the next class now. Thank you.